Weight and Balance 3.1 Weighing the aircraft and determining the empty weight center of gravity. Today, we transition from theory to practicality as we delve into the actual process of weighing airplanes and determining the crucial center of gravity. Weighing the aircraft and determining the empty weight center of gravity. This session promises practical insights, including handy formulas to measure CG locations in inches from different datum points and as a percentage of the mean aerodynamic chord, Mach. Let's ensure our aircraft are not only airworthy but optimally configured for the skies. Meeting aircraft weight and balance requirements. Regulations do not impose regular weighing for privately owned and operated aircraft. Typically, weighing occurs during initial certification or following significant alterations affecting weight and balance. The paramount focus is on safety, with manufacturers conducting comprehensive flight tests to establish loading limits crucial for safe operation. Efficient weight distribution addresses not only overloading concerns but also ensures the center of gravity, CG, stays within established limits for proper controllability. Every Federal Aviation Administration, FAA, certified mechanic is obligated to provide pilots with precise weight and CG information. The pilot in command, PIC, holds the responsibility of comprehending the aircraft's weight, CG, maximum allowable weight, and CG limits. An exhaustive weight and balance report, complete with an equipment list, is indispensable. Records used for CG adjustments maintain reliability for a limited period, necessitating periodic weighing. This is advisable after extensive repairs, major alterations, or when flight characteristics are deemed unsatisfactory. Mechanics overseeing repairs or alterations must ensure authorized weight and CG limits are not exceeded and update the empty weight center of gravity, EWCG, data in the aircraft manual. In essence, weight and balance represent an ongoing commitment to safety and efficiency, ensuring aircraft consistently operate within optimal performance parameters. Essential equipment for aircraft weighing. Now, let's discuss the gear required when weighing aircraft. Our main players are platform scales and load cell scales. Platform scales or ramp wheel scales are simple, low profile, and reliable. Roll or push the aircraft wheels onto the scale pad at ground level, with one scale per wheel. They can handle up to 60,000 pounds. Load cell scales are a more economical option, allowing you to weigh the aircraft in its level flight attitude. Jack it up, slide electronic load cells in, and get the weight on the control panel. It involves a bit more effort, but some find it preferable. Regardless of platform or load cell scales, it's crucial to maintain them well. Regularly check their accuracy, especially with daily use. Calibrate them at least once a year, and if adjustments are needed, send them back to the manufacturer. Aircraft weighing preparation. Ensuring accuracy and safety. Now, let's delve into the essential steps before weighing an aircraft. Here are the key considerations. Scale preparation. Inspect and zero out mechanical and electronic scales before use. Ensure they're in the same environment as the weighing process and have stabilized in temperature. Weighing environment. Preferably, weigh the aircraft inside a hangar to avoid wind interference. Ensure the aircraft is thoroughly clean inside and out, paying attention to the bilge area. Equipment list. Confirm that all required equipment is installed according to the equipment list. Correct the weight and balance record if any non-listed equipment is installed. Ballast. Ensure all required permanent ballasts are secure. Remove any temporary ballasts that aren't supposed to be there. Standard weights. Use established standard weights, but if actual weights are available, use those. Note the weight difference with temperature changes. Fuel handling. Drain fuel is specified by the aircraft manufacturer. Residual fuel is considered part of the empty weight. If draining isn't feasible, weigh the aircraft with full fuel and adjust afterward. Oil. Draining engine lubricating oil is necessary for accurate weighing, except for aircraft under specific regulations. Aircraft with full oil should follow specific procedures, and undrainable oil weight must be considered. Other fluids. Ensure hydraulic fluid and other operation-critical fluids are at their operational levels. Exclude fluids like drinkable water from the empty weight. Aircraft configuration. Refer to the aircraft service manual for landing gear and control surface positions during weighing. Jacking the aircraft. Aircraft can be weighed on ramps or by jacking. Special care is needed when jacking, especially for spring steel landing gear. Follow manufacturer recommendations and level the aircraft using load cells or by adjusting air pressure. Safety considerations. Install stress plates if specified by the manufacturer. No movement allowed if someone is inside during jacking. Ensure jacks are straight and raise them simultaneously. Use safety devices to prevent tipping. This comprehensive preparation ensures accuracy and safety in the aircraft weighing process. Let's move forward with a commitment to precision in our aviation endeavors. Center of gravity determination, unveiling the aircraft's balance. Greetings aviation enthusiasts. In this segment, we'll unravel the mystery of determining an aircraft's center of gravity. Picture our aircraft in a hangar, perfectly level, poised for flight. We initiate the process by dropping a plumb line from a specific reference point, known as the datum, and marking it on the hangar floor. A chalk line follows the aircraft's longitudinal axis. Subsequently, lines are drawn between the main wheel weighing points, and the nose wheel or tail wheel position is marked on our chalk line. Now, let's introduce measurements into the equation. Precise measurements between the datum and weighing points provide what we term as arms. These arms become essential in our weight and balance calculations. The next step involves some number crunching. We add up the weight and the moment of each point to find both the total weight and the total moment. And now, the grand reveal, the center of gravity. It's determined by dividing the total moment by the total weight, providing us with its location relative to the datum. Let's delve into a practical example for clarity. Imagine our tricycle landing gear plane on the scales, brakes off, secured by chocks. By subtracting the chalk weight from scale readings, we obtain net weights. Multiplying these by their respective arms yields moments. In the example, our net weight is 2,006 pounds, and the center of gravity sits 32.8 inches behind our chosen datum, which is the firewall. The entire process is outlined. That's the science behind finding the aircraft's balance point. No smoke and mirrors, just numbers and a bit of chalk. Center of gravity and mean aerodynamic chord. Moving on to essential concepts in aircraft balance, center of gravity, CG, and mean aerodynamic chord, MAC. The center of gravity, CG, holds pivotal importance in aviation, governing the aircraft's weight and its distribution. Alterations to equipment necessitate precise documentation in maintenance records. The CG, an imaginary point where opposing moments balance, is crucial for weight and balance computations. Deviation from CG limits significantly impacts the aircraft's performance and characteristics. In smaller aircraft, the CG's location is measured in inches from the datum, while larger airplanes express it in relation to the wing's width, maintaining the delicate balance for optimal and safe performance. Mean aerodynamic chord comes into play in aircraft design. It represents the average chord of an imaginary airfoil with the same aerodynamic characteristics as the actual one. The MAC is expressed as a percentage of the wing's total chord. The CG's location and limits are then expressed in percentage of the chord or percent mean aerodynamic chord. For simplicity, light aircraft express CG ranges in inches, while transport category aircraft use percent MAC. Understanding these relationships ensures proper longitudinal stability, with the CG ideally located ahead of the wing's center of lift. Expressing both in terms of percent mean aerodynamic chord simplifies design and operational considerations. In conclusion, these concepts form the bedrock of aircraft balance, ensuring optimal performance and safety in flight. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.